What secrets are hidden inside a snowflake? When winter comes, we like to look up at the sky, wondering, will it snow today? We wait excitedly for the first snow, and when big snowflakes fall, we sometimes make snowmen. Seeing snow-covered white roads makes our hearts calm and quiet. But snow does not appear just because it is cold. Water vapor needs a very tiny seed to become an ice crystal. A tiny particle, like dust in the air, plays this important role. Without a seed, water cannot freeze easily even below zero, and it may stay a little unstable. When water touches a dust particle, the ice crystal begins to grow quickly. The first shape of a snow crystal is usually a hexagon. We can understand why if we examine water molecules. Water is made of 1 oxygen and 2 hydrogen atoms. This combination creates a weak pull called a hydrogen bond. Water molecules connect like holding hands and try to find the most comfortable distance and angle. This stadial arrangement often forms a 6-sided ring. That is why a snow crystal usually begins as a hexagon. No matter which snowflake we see, they all start in a similar way. Yet, there is a saying, no 2 snowflakes are alike. In 1885, Wilson Bentley took the first photographs of snowflakes. He left behind thousands of pictures, and every snowflake in them looked different. The reason is simple. Snowflakes grow while floating in clouds. Temperature and humidity change only a little, and these small changes can affect the length and shape of the branches. They all start from the same hexagon, but their paths are different. They end up looking very different. While natural snowflakes record the conditions around them, the snowflakes created by the mathematician Koch record rules. The Koch snowflakes follow very simple rules over and over. We start with a regular triangle. We divide each side into 3 parts and add a small regular triangle in the middle. Then, we repeat the same steps on every new side. At first, the triangle's edges are smooth, but step by step, it grows jagged like the teeth of a saw. Then, something very strange happens. The outer edge keeps growing, and the perimeter seems to stretch on forever. But the total area stops growing after a certain point. The area is limited, but the perimeter goes on forever. No wonder mathematicians were puzzled. It becomes even more fascinating when we examine the Koch snowflakes closely. If we zoom in on a small part, it still looks like the whole snowflake. This is called self-similarity, and it is a fractal. Nature often grows this way. Coastlines, mountains, tree branches, and even lungs all show it. It may look complicated, but we can see the traces of a single rule repeated many times inside. That is why snowflakes reveal 2 things at once. One is nature's secret, the stability of the hexagon made by water molecules. The other is the mark of variation. Even the same rule can create very different shapes when conditions change. On a snowy day, when a snowflake lands on our hand, it is not only the snowflake that disappears. A rule glimmers for a moment and then vanishes too.